So when you are factoring out, it is the same as dividing them out, okay? So we are dividing -3, and what will I have left after I divide -3 from the first term? X. And when I divide -18 by -3, I will have +6. And what could I do to check and make sure that this is actually accurate? Distribute back again the other way. So -3 times x is -3x. -3 times +6, -18. That's the same as what I had here. So I know that's correct. All right? Very important. You need to factor out a negative if it is first. All right, now let's get into these expressions below. It says, are the expressions equivalent? Sketch and simplify to prove. If the two expressions are not equal, write the correct equivalence. Okay? So you may already know whether they are equivalent or not, but we want to be able to do a sketch with those. All right? Here we have a product of the lengths of our large rectangle. And we kind of talked about this yesterday. Okay? So you want to start out by making a large rectangle. Okay? So go ahead and add that on your paper. And what I did, it's kind of overlapping, I just put it in there. So as I look at this, what is the width, the short end, this side over here of this rectangle? What is that length? If I'm looking at that first expression. 3. Yes. Okay, so that has a width of 3. And what about this length up on top? What is that going to be looking like? A little bit louder. No. X plus 3, right? I should have given more space here. This is your, I'm just going to say length and width. It is a product, so length times width. So the width up here is going to be x and plus 3. Okay? Now, this over here, this is a sum of our two smaller rectangles. Okay? So I'm going to put this in here to separate them. And now that I know I have a width of 3 and a length for that smaller rectangle of x, what is the area of that first rectangle? 3x. And I see over here I have 3 as the length. My width on top is 3. And what would be that area? 9. So this is 3x plus 9. So are these two equivalent then? No, they are not. So I would need to rewrite, it says write the correct equivalence. So I would say the correct equivalence is 3x plus 9. They're not equivalent. The equivalent answer is 3x plus 9. Let's put not equivalent. Questions on that? So you are having to draw the sketch now. And they're off to the races. Questions on that? All right. So let's take a look at number 2. Number 2, this is my product. This is a product that is being multiplied. So this is your large rectangle, one large rectangle. I'm looking at, I don't know if it would draw. Looking at length, I'm going to call this length, it's just easier. And width is on the top. So what is my length on the side? Anyone? 6. And what is my width? Y plus 1. Okay, there it is. Now I'm looking at the sum of my areas, and that's the two smaller rectangles. So I am going to separate those like so. And what is the area of the first rectangle? 6y. What's the area of the second? 6. Are those equivalent then at the top? Yes. So yes, these are equivalent. Those two are equivalent. Questions on that? All right, I got one more slide. Did everybody get that written down? Okay. Two more. So we have x times x plus 4 and x plus 4. I wonder if I forgot to include one there. Did I write that correctly? X squared. I skipped it. Yes, this should be x squared. Because I couldn't remember how you do a square in, it's not PowerPoint. What's the Google equivalent? Whatever it is. Is it Google Docs? PowerPoint and whatever it is. All right, so x times x plus 4 and x squared plus 4. Go ahead and let's see if we can sketch these. So the first one is a product, which is your length times your width. Bless you. And so I need one large rectangle. What is my length? X. So I'm going to put that on the left. My width up on top is x plus 4. Okay. And then I am going to have a sum of two areas, like so, and like this. Sum of two areas. And so the area of the first rectangle is x squared, and the area of the second one is 4x. So are these two equivalent as they have given them to us? They are not. So we cross this out, and the equivalent to x times x plus 4, quantity x plus 4, is going to be x squared plus 4x. Any questions there? And the last one. See if you can do this last one on your own if you haven't already. And then just check. I'm going to do this up at the top. Check and see if you're on the right track. Bless you. Man, allergies? Maybe? All right, so as you are finishing up, take a look at those, see if you got the same answer. Okay. All right, so does everybody see those are equivalent? We have xy, or y times x plus 2. That's the product. And then we have, okay, thank you. And then we have the sum of those areas, which is xy plus 2y. So yes, those two are equivalent. All right. How much space do you have? You have some space left somewhere, don't you? Just say yes, it's quicker. Yes, it's quicker. All right, so this seems to appear, this is the review, but I'm not going to give it to you yet today. But there's a couple on here that are a little more challenging, okay? So somewhere on that paper, I want you to add these, okay? And I'm going to try to do a drawing here. So let's say I have this. Yeah, it looks good. Maybe a little bit longer. Because I remember this being on the things like this on the test, and people are like, we didn't really go over that much. All right, so here is a picture. Okay, here is a picture. Can you give me the expression that represents that picture? Can you give an expression that represents this picture? So that's the first one. And while you're thinking about that, yep. All right. So let's do some thinking here. I need an expression that represents this picture. Now, it looks different from all the other ones that we have because what we have on the right-hand side does not have the same length as what we have on the opposite side. Does anybody have an idea of what this expression might be? Is that a hand or no? Which one? For this one. This would be, we'll call this number 5. So problem number 5, what is that expression? Yeah. 3 squared? So 3, tell me exactly what you put. 3 times. Okay, so then try to say parentheses. So 3 parentheses. N parenthesis, and then squared, like that. Okay. What do you guys think of that? Now this is separate. This is separate. You're not looking at that at all, right? Okay. Does this picture represent what we have there? What would you say? In this case, if it's 3 times quantity t plus 4 n quantity squared, excuse me, according to order of operations, what would I have to do first? Well, we're not solving, we're just simplifying. So I would have to find t plus 4 squared. Do I have t plus 4 squared? Do I? How many rectangles do you see in this picture? You're like, this is why I'm doing this. This is good. How many rectangles do you see in picture or problem number 5? 2. What is the area of the first picture or the first rectangle? 3t, because it has a length of 3 and it has a width of t. So that is 3t, right? So everybody with me there? Now take a look at the second rectangle. What is its length? And we'll call this length because that's the way we've been doing it. 1. And what is its width? 4. And so what is the area of that rectangle? 4. So if I put those together, what is my expression there? 3t plus 4. Now, we haven't had one of those, right? So it doesn't, it would seem logical that maybe we don't quite get it. Now, can I write this as a product of a larger rectangle? Can I factor anything out from this 3 and this top, which is, what is this top? Essentially, it is t plus 4, right? So here, can I factor anything out? No, because over here, we don't have the same length or width, whatever you want to call it. Okay, so we can only look at this as a sum of 2 separate areas. So this works, but we cannot write it as a product of length times width. Okay, does that kind of make sense? You will see some pictures like this, and that's why I wanted to bring that up. All right, and I appreciate you for trying to do that. Okay, but it's only 3t plus 4. Now, find one other area, and let's talk about r plus 2 squared. R plus 2 squared. What does r plus 2, that quantity squared, mean if I were to write it out? And I'll let you determine what that means. Write it out. A little bit louder. What would it? Wait a minute. Are you starting over now? Okay. One more time. Yes. This is what it means, right? This means r plus 2 times r plus 2. All right? R plus 2 times r plus 2, is that a product or is that a sum? It is a product. This is your length, and this is your width. Can we make a large rectangle from that? Yes, we can. Feel like Bob the Builder. Can we build it? Yes, we can. All right, r plus 2. That is your length. So I need to put r, and we've had like r plus 4 is right here. So r plus 2, I would put 2 there, right? So on the top, I am multiplying by the width, which is also r plus 2. So in this case, though, this is my large rectangle. How many smaller areas am I going to have inside this large rectangle? 4. Because I'm going to have one that's right here. I'm going to have one that's here. I'm going to have one that's here. And one that is here. Okay? What is the area of this rectangle? R squared. It is r times r, right? So that is r squared. What is the area of this rectangle? 2r. It is r times this 2, correct? So that is 2r. Can you see that green very well? Yeah, well enough. All right, coming down to the bottom left, what is the area of this rectangle? 2r. And finally, the area of this rectangle over here? 4. It is this 2 matched up with this 2 here. 2 times 2 is 4. So when I put it all together and I simplify, you would have what? R squared plus 2r, which is going to simplify to be plus 4r plus 4. But what I want you to notice is this is what the picture is going to look like. All right? Because you're going to have to be able to draw the picture. Questions on that? Any questions? Miss Thede, what if we had something like r minus 3 squared? We have a negative in there. How am I supposed to show that negative? I'm glad you asked. Who said that? All right, so in that case, it would be r minus 3, r minus 3. You are still going to have 4 of these, but even though it is a negative, this is the negative amount. So for this particular rectangle, what would be the area of that rectangle? Negative 3r. And what would be the area of this rectangle down here? What is it? Negative 3r down there also. This would be r squared, and a negative times a negative would be positive 9. So putting that all together, r squared minus 3r plus 9. I guess what I'm saying is don't worry about the fact that these are negative. We're talking about the area, okay? These would be combined, and you get r squared minus 6r plus 9 when you would simplify. So I just wanted to bring those up because I know it's going to be on the review, and if I tell you now, you have a better chance to get that done. Okay? Any questions about that? All right. Now, here are a couple of announcements. We are essentially done with taking notes today, okay? Grading, still grading, forever grading. Homework, Unit 1, 3 on Canvas. I would like that to be done by Tuesday if possible. Some of you, I just opened it up tomorrow or today. Man. On Monday and Tuesday of next week, we will have a card sort activity. So I have matched you up with a partner based on that little expression quiz that wasn't for a grade. So that will be interesting. We always have a card sort activity. It is harder than you think. It'll take you back to your kindergarten days, okay? We will review on Wednesday and Thursday. So right now I'm planning to give you the review on Wednesday. You will work on it Wednesday in class and try to work on it Wednesday night. Thursday, I will answer any questions that you have on it. And then Friday is our test. Okay, so that's what we're looking at. All right? Okay. More of I have, who has. I think we will try this. So if you would like to get a whiteboard, help yourself get a whiteboard. I am going to read these cards out loud, or if you just want to do it on a piece of paper or something in front of you, you can. If you want a whiteboard, you can. But these were the harder cards that we were trying to do the other day, and you didn't have anything to write with, and it was like trying to keep it all in your head, and it was a little bit difficult, okay? So get out a whiteboard, dry erase board, or I want to see you working on these problems, okay? And we'll see if I can write them down so it's visually available to you. All right. Here is the first one. Oh, no, that's not what I wanted. Back. Here we go. So, you need to, here's the first one, add 10 to 3 times, watch, these first couple will be easy or something, a number. Add 10 to 3 times a number subtracted from 1. And I have not done this ahead of time, so I don't know the answers. I will be doing the answers with you as well, which means I may make a mistake. Got too many things to hold on to. So add 10 to 3 times a number subtracted from 1. So here it is. I have, or add 10 to 3 times a number and subtract from 1. What did you get for an answer? Don't worry about being right. I mean, I'm looking for the right answer, but these are more difficult. So who has an expression for me? Can you say it? What'd you get? Okay. So we have a number. We have to use and leave that as a variable. So you're newer to the class, so I'm just going to point that out. No biggie there. Anybody else have an answer? (3n plus 10), and then what? Minus 1. Can you simplify that? Can you? Okay, so that would be 3n plus 9. Okay, so we have our first answer. Anybody else get 3n plus 9? You got 3n plus 9? Okay, how did you do it? You need to speak up. 10 plus 3n minus 1. Okay, and you got 3n plus 9. And somebody else over here got the same? Anybody get anything different? Now, it says, and I got something different, and maybe I'm wrong. Add 10, so I'm going to say plus 10, okay, to 3 times a number. I'm adding 10 to 3 times a number subtracted from 1. What is being subtracted from 1? I can't hear you. Yeah. So add 10 to 3 times some number, but this number is what is subtracted from 1. Do you see that? So we're not subtracting 1. It's not 3 times the number minus 1. It is 3 times the number that is subtracted from 1. If I put this together, I can combine 1 and 10 to get 11 minus 3n, or negative 3n plus 11. That is the correct answer. So these are harder. Do you see the difference? It's not 3 times the number subtract 1. It's 3 times the number that is subtracted from 1. Okay? How much time do I have? I don't have any time left, do I? Ah! All right. So we will still work on this. Please make sure you put those whiteboards back up. Make sure you are working on homeworks 1, 2, and 3 on Canvas. And we will